Hello, everyone, and thank you for joining me for this presentation on Mammoth Ivory rods from the Middle Tanana Valley. This is a presentation about ivory rods from Shaw Creek in interior Alaska, but it's also a conversation about where they fit into the broader picture of the Pleistocene peopling of the Americas. There has been a revolution in Pleistocene archaeology of the Western Hemisphere, and in the last 12 months, a fluorescence of works have come out, both in the popular literature as well as the scientific journal literature. These three books, First Peoples by David Meltzer, The Indigenous Paleolithic of the Western Hemisphere by Paulette Steeves, and Origin, A Genetic History of the Americas by Jennifer Rath. Each are excellent works. They're inspiring to read, and this is truly a tremendous time to study Pleistocene archaeology. But I will add that the three of these each present a different chronology or timing for the first steps into the American continents. So there's no consensus even among pre-Clovis thinkers for when and even how or the route the first people entered the continents. There's also been a strong favoring of the early peopling via a coastal route among most of the recent works that have been reviewed. Despite this, there still are no undisputed or incontrovertible evidence for sites older than 12,000 years ago along the southeast coast of Alaska and of northern British Columbia. I think, though, that we can agree somewhere in Beringia lies the keys to the questions regarding timing and routes for the first people. Most hypotheses center around two different corridors that would have been unimpeded by the Cordilleran or the Laurentide continental ice sheets over Canada. Late Pleistocene human migrations into the Americas probably occurred from interior Siberia by multiple groups of people arriving into eastern Beringia, where they probably were at that time blocked from moving further south, at least initially. So one of the questions is, when did they first arrive into the glacier-free regions of interior Alaska? The models project that it was either by land or by sea. If by sea, we should expect to see evidence for an eastern migration inland along all or portions of the West Coast, whether that's from Southeast Alaska or the Northwest Coast, Washington, Oregon, and even California. Even if the land strip that they occupied initially during the LGM, before or even immediately afterwards, is submerged, if that land is completely submerged, we should still see movement from the oldest to the latest from the West Coast into the interior, and we just don't have that evidence. Moreover, there is exposed coastline of what looks like habitable refugia along this coast that has not been submerged and is still above the modern sea line. Many of these date between 17,000 and 12,000 years ago. Shouldn't some of these have evidence of human activity? Unsubmerged sites still do not provide convincing evidence either for human settlement of land use, although admittedly looking under the ocean for archaeological sites presents a host of unique challenges. So in this talk, I want to evaluate some of the evidence for either a coastal route or an interior ice-free corridor route and the timing of those events. Ben Potter in 2018 argued that multiple models were possible for the peopling of the Americas and that both routes were viable between 15 and 13,000 years ago. He's reviewed the literature and the data in this paper, and habitats existed in both corridors. But as Potter points out, and this image shows nicely, all early sites older than 13,000 years ago are interior oriented, mobile, hunter gatherer fishermen, and they're not marine coastal oriented technologies before 13,000 years ago. Arguments for early coastal migration, say pre-LGM, often center along the coast or the so-called kelp highway, with some arguing for a source population among the ancient Hokkaido people, northern Japan. And many pre-Clovis or early adherents to a very early colonization event argue that many of these sites listed here offer evidence for people in the mid-continent well before 14,000 years ago. So these sites offer possible evidence for a pre-Clovis population. However, source populations based on bioevidence, genetics, and teeth does not support Hokkaido as the source population for the first Americans. And there are many questions of dating methods and artifact contexts in each of these arguably pre-Clovis sites. And without going into specifics for each and every one of them, the concerns rely on the only use of OSL dating in absence of radiocarbon dating at sites in Texas, for example. We have seen in Alaska and in interior and south central Alaska that after 8,000 years ago, many of these OSL dates are starting to range unusually old when compared to the tried and true method of radiocarbon. And so I don't accept ages of 17,000 years ago based solely on an OSL chronology. So dating methods are of concern, but so are context. If you only find a few artifacts in a stratum that is older than 13,000 years ago, there are many ways that those can get into those positions, especially if in an environment, say at the bottom of a lake or pond. I've seen even in aeolian sediments, artifacts can move through bioturbation and other natural forces that can bring some artifacts from above to lower deposits. So archaeological evidence for a coastal migration after decades and decades of research remains unconvincing, to me at least. I'm not saying it didn't happen that way. I'm saying I haven't seen the definitive proof of there are no uncontested archaeological sites anywhere along the West Coast. And there also are not signs of a migration moving west to east across the mid-continent of North America. So even if the earliest sites are submerged under the ocean, I don't see the evidence of them moving inland. The opposite happens to be the case. So source populations originated in continental Siberia, and their technologies are oriented towards hunting in this interior steppe type environment. This is based on the genetic ancient DNA and lithic data. Also, there is a rich osseous tool tradition that goes back at least to 30,000 years ago, where artifacts are being made from mammoth ivory primarily, but also on bone and antlers and tools. And this makes sense for an environment that is low on good woody plant materials. So in Western Beringia and in Eastern Beringia, we have a range of sites that show different activities, different ecological zones, and different toolkits being adapted to these environments. And a very nice chronology exists for how they were colonized over time. So as Graff and Bouvet point out through their analysis of stone tool technology, there are multiple possibilities for people moving into Alaska. And realistically, there were, even based on genetic data, between 2 and 4, at least, groups moving into the eastern Beringia, where there may have been a standstill for an unknown period of time, possibly beneath the Bering Straits. But the reality is that in this area of the Russian Far East and in Alaska, we don't have the deep time archaeological presence for people moving into this area, say before 17,000 years ago on the west side in the Russian Far East, and no direct evidence prior to 14,100 in Alaska. Now, presumably some people were there before, but the size and the scale and the length of time remains unknown. Potocko has done a fabulous job of documenting the osseous tool traditions, and it's a very rich history over in Siberia. And it's from this tradition that we find people in eastern Beringia and Alaska that know how to find and use and create ivory tools out of the resources that were present there in the late glacial. So we focus our attention towards this interior route in the absence of other evidence. I will admit that the interior route is also void of sites that predate 12,000 years ago, and much more work is needed within the ice-free corridor to better understand its ecology and perhaps early archaeology. In eastern Beringia, there is a strong archaeological record for initial human colonization via an interior route, or at least at the northern gate of this corridor. Between 14,100 and 12,500 years ago, there's unquestionable evidence for human presence, probably by multiple groups converging in interior Alaska from somewhere further west. There are multiple technologies. We have different type sites, upland and lowland subsistence activities, and strong evidence for different stages of human colonization in this region. In mid-continent North America, Clovis is the earliest verifiable presence, dated between 13,200 and 12,800 years ago. This is a map with the fluted point distributions, and radiocarbon dates support that the fluted Clovis point, the iconic fluted point technology of Clovis, probably originated in southeastern United States or the southern Great Plains and spread through an existing populace towards the north. So this does suggest that Clovis does not come from Alaska, to be very clear. The fluted point distributions support a northern spread of this tool. So in the absence of diagnostic tools in Alaska pointing us in the direction of the first Americans, I'm looking at the organic technology. And the spread of ivory rods among Clovis assemblages has been well documented, but none are older than 13,000 years ago. So we're left with the ice-free corridor. Recent studies and ice sheet maps indicate it is available by 14,000 years ago. And we should be paying more attention to migratory waterfowl and smaller game in the corridor as being attractive to the first Americans, rather than focusing keenly on megafauna hunting, particularly of woolly mammoth during the late Pleistocene. So part of the key to this is their subsistence strategies. This is the same map of ice extent, but plotting only rods and points or organic tools. In red triangle in Alaska are the ancient Alaskan sites, those that would predate 13,000 years ago. In the upside down blue triangle are Clovis era sites dated securely from the mid-continent. Then there are a number of post-Clovis and a few unknown or undated specimens that we've included in this analysis. Note the availability of the corridor as early as 14,900 in these maps by Dalton et al. In 2020. And by 13,500, 500 years before the first Clovis appear, the corridor is fairly wide. Form and function of ivory rods is important to note. There are 4 variants of osseous rods as defined by Mark Sutton. Number 1, the straight unibeveled. Number 2, straight bibeveled. 3 is a curved unibevel. And 4 is a bipointed style. In cross-section, there are round, oval, or cylindrical types, commonly bibeveled. There are plano-convex or split horizontally varieties, and some rounded or oval forms have been beveled on the edges to make more rectangular cross-sections. The beveling of the ends is an interesting feature. 1 or 2 beveled ends appear on these rods. Commonly, the size of the bevel ranges from 50 to 280 millimeters. In terms of function, foreshafts or projectile weapons are probably the favorite explanation, but there are many excellent hypotheses for other uses, such as a wedge or a lever, which I find useful. Having tried to sample the core of a mammoth tusk, I found that after cutting incisions in the tusk, a flat Stanley screwdriver was a very effective tool to use. And so use as a wedge is one of my favorite explanations. Others have argued for fishing spear components or flint knapping pressure flakers, sled runners, or hide working tools. Probably any and all of these options were available to the users of these tools. Later forms are incised along 1 or 2 edges in order to insert stone microblades, but these tend to date to the Younger Dryas or later in Alaska. Mid-continent, there are many comparative Clovis era bone and ivory rods that do not exceed 13,000 years in age that we can look at as a comparison for the people from interior Alaska. And if this is a marker of technology or in any way a form of ethnicity based on tool type, it is interesting that we can compare the finds from Holzman to, say, Sheridan Cave, Ohio, or Anzac even. The 4 oldest sites that are that have bone or osseous rods in them include Anzac in Montana, a bibeveled rod, at Sheridan Cave, Ohio, where there's a unibeveled point, and Blackwater Draw, New Mexico, which has a unibeveled point. East Wenatchee has the largest assemblage, and some of these are engraved, and they're bibeveled rods in there as well. So in this study, we looked at 77 bone and ivory rods that probably date to late Pleistocene, early Holocene, and there were 39 of those that were complete or nearly complete enough that we could put into this length and width scatter plot here. And you'll see that the ancient Alaskan rods from the Holzman site cluster nearest to Sheridan Cave. And at Broken Mammoth, the variability is all over the place on either side of the Anzac points. Here are the organic tools from the Broken Mammoth site, osseous tools coming from cultural zone 4, which dates between 13,700 and 13,100 Cal BP. There are brief reports by Hepner in 2017, Holmes in the Fred West book in 1996, and Yesner publication in 1994. Bone rod here with one beveled end. There's an antler point and one particular bibeveled handle that you see in the middle, OA4. And then OA5 is probably the one that is most similar to the Holzman and Clovis rods further south. At the Holzman site along Shaw Creek, just around the corner from Broken Mammoth, about 2 kilometers from Broken Mammoth, maybe a little less, there are at least 8 stratified components that are sealed in Aeolian sands and silts and loess that have piled up over the last, 15,000 years or more. Cultural components beginning with cultural zone 5B, dated to 14,100 to 14,000 or to 13,800 years ago, and component 5A dating from 13,800 to 12,800 Cal BP. And then a very strong and robust Younger Dryas occupation in component 4. And just have a look at component 2, where a very strong lithic assemblage was found in situ, demonstrating the nature of these deposits. You can actually tell where the flint napper sat and flint napped on the left knee and then switched over to the right knee and left debitage lying around of all the same raw material in component 2, early to middle Holocene age. So preservation is pretty well in terms of the in situ nature of these assemblages. There are 7 stratigraphic units at the Holzman site that contain these components, and the radiocarbon dates here are at the right. We have congruent radiocarbon ages from human activity areas, the chronology and stratigraphy with sealed cultural components. There are 8 different periods of use at the site, some of which contain multiple occupations. And there's at least 11 to 18 centimeters of sterile loess that separates the lowest 2 components, component 5A from component 5B. These are the radiocarbon dates from the lowest 2 components, 5A and 5B. There's possibly 5 separate occupation events in 5A, dating between 13,800 and 12,800 Cal BP. In component 5B, the earliest component, a mammoth tusk, was recovered. And this just demonstrates here all of the late Pleistocene dates from Shaw Creek on human activity events, or if it is a serial number with an asterisk at the end, it is on ivory. And this shows the overlapping coeval nature of mammoth in the area based on the dates on their tusks, and human activities based on dates from hearths. So the 2 were in the area together, and there is some evidence for mammoth hunting of juveniles at the Swan Point site further up Shaw Creek from Holzman. These dates demonstrate that both fresh and ancient ivory was used by the first people to enter Shaw Creek at 14,100 years ago. Here's the excavation of component 5A of an anvil and a hearth activity area dated between 13,600 and 13,400 years ago. You can see the large anvil there, the blow up, and little bits of ivory and some bone fragments lying around, with the hearth showing mostly as reddened burned earth with charred bones. And in these bones from component 5A, I am seeing quite a bit of waterfowl fauna, like bird bones, most likely like dabbling duck size bird bones. The zooarchaeological analysis from Holzman is still ongoing. I think that in this component, they are reducing mammoth ivory into these blanks that you can see here, along with other activities, but we have in situ fragments and slabs of ivory throughout this component, and we have quartz, which is local to Shaw Creek bluffs, being used as scrapers or even planes to carve these down and shape them into manageable blanks that can be carried off-site and taken away. Here's a map of the lower two components with a big gold star indicating the location of where these ivory rods were located in relation to smaller hearth features and a scattering of ivory in component 5A. Most of the fauna from this map is of mammoth ivory. So the Holzman mammoth ivory rods from component 5A, there are two of them, 16-601.1 and 16-601.2. The first artifact has 5 conjoining fragments. It wasn't in as good of shape, has a rounded proximal base with a slightly beveled distal tip and rectangular to somewhat rounded corners. It has a slightly flat cross-section and was fractured longitudinally up and down. It's directly dated by one of these fragments between 15,580 and 15,500 Cal BP, and this overlaps with a nearby hearth containing bird bone and other burnt items, some burnt twigs. Representing this date represents one of the youngest mammoths in continental Alaska. Soon after this, there are no fauna dated after, say, 13,500. There is another example of a mammoth ivory of this age from Broken Mammoth as well. The dates really kind of overlap other activity areas, and this particular artifact is not as well preserved as artifact 2, which consists of 2 conjoining fragments. It's a little shorter, but it was split in the middle in half, and it has bibeveled ends with striations on it. The lower, the second bevel is not as well preserved as the top one in this figure. The bevels in this are not huge. They're on the lowest end of the spectrum at 17 to 11 millimeters respectively, but the weight is higher, 10.6 grams compared to the longer artifact 1. So just to conclude, I've talked about bevel points and rods as a staple a component of late Pleistocene technology. It originates in Siberia and comes to Alaska and then the mid-continent, North America. And this offers us an opportunity to discuss the continuity of osseous technology in Paleolithic migrations. There is preference for ivory over bone in Eurasia and Alaska, but bone is more often used in the mid-continent of North America among Clovis peoples. 2 late Pleistocene ivory rods from Holzman and osseous tools from Broken Mammoth predate those found among the Clovis tradition some 500 years later, right on the southern end of the ice-free corridor in Montana and other places around the mid-continent. The oldest known examples in the Americas of this kind of tool is in interior Alaska at Holzman and Broken Mammoth. This places people and technology in the right place at the right time for a southern migration through the ice-free corridor sometime after 14,000 years ago, and maybe even after 13,500 years ago. And keep in mind, this is still a millennium or a half a millennium, 500 to 1,000 years of time to colonize quite a lot of territory. Fluted point technology emerges later in Alaska, much later in the early Holocene. So this has been a summary of mammoth ivory rods in Eastern Beringia, American Antiquity from 2022. I thank you for your attention.